Good morning, everyone. So I'm Pierre Tane from UIC. So for people that don't know UIC, it's an international union of railways consisting of roughly 200 members across the world, both on the infrastructure, so running the rail networks themselves, but also on the railway undertaking side. And so when we look at innovation and railways together, at the end of this decade, we will be witnessing, when we see a train passing by, more or less 150 years of continuous innovation, because the mechanics of the train, for example, the conical wheels that allow self-centering on the tracks, have been invented back in the mid-19th century. When it comes to signaling, it's more or less the 20th century, and when it comes to telecoms, by the end of this decade, hopefully, we'll see the first deployment of FRMCS, which will be based on 5G and so 21st century connectivity. One aspect of this is that railway. Sorry, I'm not. I need that. No, it doesn't work. Let me give you back this.
Yeah, of course.
Here you go. Wireless technology. One aspect that is distinctive in railways is this span of technology that essentially spans decades. And on the lower right end of these slides, for example, we see what used to be the interlocking at Paris-Gare de Lyon, which was installed back in 1933 and was replaced last year, so 2024, by a new digital signaling system that is centralized, and so none of this exists anymore. But and part of this, one of the reasons around this maintenance of multiple technologies and decades of technologies is that there is obviously a significant investment in railways for buying trains, but also for the infrastructure itself, which is an infrastructure that spans thousands of kilometers as well, not always in city centers, so it brings its own challenges of maintenance, for example. And so long-term life cycles, 50 years is definitely not unheard of in railways. And when it comes to datacom, for example, usually we're more talking about at least, if a decade, then that's a good start. There's also a strong attachment to maintaining availability of the network. The trains need to keep running. Not only the passenger train that we see that would carry us through between cities, but also freight trains that also utilize part of the rail infrastructure at night, which has its own challenge. And there's also all this attachment about making sure that the railway stays safe for the transport of passenger and goods, which leads to a very, very conservative, some would say, or at least prudent, I would say, approach to innovation. And this diversity further expands because if we look at from the perspective of the train, from a telecom perspective, you still have in Europe people running in some places with analog radio, alongside GSMR, which is the current wireless technology in most railways in Europe, and also there's large deployments in the world, like in China, for example. And so upcoming FRMCS, and so one of the challenges that we'll have in this particular case of telecoms is that because stakeholders don't move at the same pace, we'll have coexistence of these systems for quite some time as well. We also have a diversity in energy supply, so we have obviously diesel, we have electricity of electrification of some of the lines, we've got hydrogen coming as well. From a signaling system, we have lots of national flavors which incurred lots of investment by infrastructure managers and railway undertakings, which ideally would be replaced eventually by CCS, which started, let's say, late 90s and still improving in its deployment across Europe, I would say. We have operating rules which are a mix of national operating rules and harmonized operating rules that apply to these systems. We have various gauges. For example, in Spain, we also have places where trains need to change the width of the axles to actually go on a different infrastructure. And all of this essentially creating a problem space for innovation and then for digitalization that's quite large. If we step back from pure technology, we also have a very, very complex stakeholder system. So we're trying to serve the needs of the passenger and the transportation of goods. And for that, we have infrastructure manager, which operate the rail networks. We have railway undertaking, which operate the train themselves. They don't have the same incentive when it comes to bringing new technology, which creates again a question of alignment. Then on a more legal basis, we have regulation at the European Union, in particular related to railway interoperability. We also have national regulations coming in play, and then we have a large ecosystem of systems that contribute to this railway system. So telecoms, I mentioned it, but also rolling stock standards, signalings, all the things around providing civils for the tracks and tunnels and viaducts and all these kind of things. And finally, standards. And to bring digitalization into the rail system, we need to somehow coordinate all this complex system of stakeholders to adopt at appropriate pace technology. Then ultimately all of this is done to ensure safety. That's a very key tenet of the rail system. Interoperability is one that is worth mentioning, because usually in IT it's more understood as systems being able to interact with each other. But in the case of railway, it actually comes with the railway interoperability, which is about allowing the free movement of trains across the European network. And that in itself implies that rolling stocks, so trains, and also the infrastructure need to comply to a set of technical standards that have been prescribed and that more or less serve as law in Europe, the TSIs. And to actually assert that this implementation has been done correctly, there is a strong emphasis towards certification. Certification being both a combination of paperwork to document what you're supposed to be compliant about, which in itself is a challenge for railways to do in a cost-effective manner, but also extensive testing. For example, in the case of GSMR, there's lots of runs that need to be done to assert that the railway coverage is actually up to certain standards. And so all of this contributes to obviously cost complication, which we would try to address in parts with digitalization. So I talked a lot about certification, which is more the left side angle of this slide, whereby the European Commission and the European Union Agency for Railways have tried to somehow simplify how to address this certification challenge by providing one shop, I would say, to establish compliance. But ultimately, certification is only part of the business challenge that railways have, and there's, in particular, in order to reduce operating costs and being more effective in maintenance, we need to do operation optimization and also improve the maintenance processes, which in some cases are still manual, as in people walking by the railway infrastructure to notice visually some of the defects. There are obviously already innovations in place to try and accommodate this, but one example where people can put trains with cameras to spot the infrastructure. But in some northern country in particular, there tends to be a lot of snow, and then the camera-based system to look past the snow is not necessarily sufficient, in which case you need to bring other innovations to figure out how to detect defects, and so there's things like using eddy currents, and so there's lots of solutions. However, they tend to be quite dispersed nationally, so that still brings the cost up. So all of this to say that in order to bring innovation in railways, we have all this legacy to consider, and also we have a necessity to ensure continuity of the service and availability of the infrastructure in particular. And so as such, it's more of an evolution than a revolution that we can introduce. Second, the question of digitalization in railways is both a technical matter, but also a question of mindset, because there's lots of current processes that are largely manual or semi-manual. And in order to address the challenges of the upcoming decades, railways will have to make a significant change in terms of their mindset. In the past few weeks, I was, for example, in Copenhagen for European spectrum regulation. One of the challenges that railway have is coexistence with public mobile networks and the harmonized bands. That in itself, considering the amount and density of public mobile network base station nearby some of the railway tracks, if we continue doing it the old way, as in looking at each individual interference case in a manual manner, it's going to be completely untenable, and so here digitization will also play a role. Ultimately, as to actually facilitate bringing that innovation, we have one very key important aspect of the railway system. It's a train, okay, that's a bit of a tautology, but it's important because currently to actually bring data from the train to the ground or to provide data to the train, so we use mostly GSMR in Europe, which is 2G based and has its own limitation. And to unlock innovation, there's lots of data that will need to be provided by the train to the infrastructure in particular, and for that we need to improve connectivity means. But it's also about connectivity between systems in the sense that we need to streamline the exchange of data between interoperable systems so that other computer intelligence, for example, based on AI, may be able to bring some benefits in digitalization. So coming back to GSMR as this means of connectivity, so it's one of the success stories of railways. It looks a bit outdated to some, probably, but that's one of the systems that's the most widely deployed in railways, and that's quite an achievement. So it's deployed obviously in Europe around 130,000 kilometers of tracks and roughly 210 in worldwide. A large portion of the non-European tracks are actually in China. So it's a 2G system with all the limitation of a 2G system, and it's planned to be supported by the industry until at least 2035. That being said, the operating costs and the maintenance costs of such a system are starting to be somewhat concerning, and as such, there is a need to provide a solution to this obsolescence of GSMR, but also to support new applications beyond the ones that are currently supported, which are essentially critical voice and ETCS in GSMR. And for that, the answer is a Future Railway Mobile Communication System program started by UIC, which is essentially built around three basic building blocks: 5G, the use of harmonized spectrum, but also extension to usage of public mobile networks where possible, and also, and I think we have speakers that will talk to us about non-terrestrial networks later. That's one of the things we looked at. We just last week I was discussing with one of the 3GPP interest group about satellite for railways. The last building block is MCX, so 3GPP mobile critical communication framework. So FRMCS is built around UIC requirements document, complemented by HCT-CRT standards, but also lots of underlying international standards, the global mobile standard of 3GPP, IETF, IEC, and for some of these aspects. So in terms of timeline, we are currently in 25. We have an ongoing project of industrial testing and validation, which is called MORAN2, partially funded by Europe. which essentially is supposed to finish by third quarter of 27. At the same time, we will finalize the UIC 3.0 specifications. And then a couple of a quarter after, essentially, the CTC-RT standard are to be complete, with the ultimate goal of combining the FRMCS angle and the evolution of the ETCS standard to transcribe them into the command control and signaling technical specification for interoperability of 2028. So it's a big stream of efforts combining into 28 on this TSI, knowing that once it's in place, infrastructure managers which have a vested interest, I would say, in evolving towards FRMCS, in particular due to the GSMR obsolescence, but not only, would be in a position to ask railway undertakings within 5 years to actually move to FRMCS. And as you see, all of this shows that innovation is on a slow pace, but it's coming. You have to be patient in railways, I would say. So commercial deployments foreseen by 2030, and then GSMR support might be extended in certain countries beyond 2035, subject to commercial arrangements. Anyway, it's an enabler, obviously, for automatic train operation, for ETCS, but it's also for lots of digitalization needs. So once you actually provide a combined, mutualized communication gateway from the train to the ground, you can enable lots of digitalization application, in particular predictive maintenance. So connectivity is the foundation of this digitalization, not the destination itself. We will, with that, we also, alongside with it, need to progress on the digital representation of the rail system. In the sense that, because of all I said about certification hurdles, and also the fact that it takes a long time to validate possible railway projects, there's quite an important trend towards improving simulation, automation, optimization through digital twins. And one aspect that I didn't go too much in this presentation, because I know Omar is going to talk to us about it, is cybersecurity. Because when GSMR, for example, was connecting one application with one dedicated modem to the infrastructure, FRMCS, and sometimes not even with IP and pure circuit switch data, FRMCS is moving to IP, enabling a large variety of applications, and that brings its own challenges. And we've seen recently that critical infrastructure of transport, such as airports, but also in the past year, there were events of cyber attacks toward railway infrastructure, sometimes cyber, sometimes direct physical attack, by the way. So that's obviously a key tenet of what we need to do for digitalization. And when we look at digital twins, as soon as you start combining digital twins with the infrastructure itself, the real infrastructure, you also have new challenges that come into play, like things like twins in the loop, I would say, could impact the cybersecurity of systems. So these digital twins, they enable lots of use cases. So just to name a few, so predictive maintenance, because maintenance is such a, so if you immobilize a train, it's very expensive, and so you need to minimize that, for example. In the same way that when you try to establish whether a railway switch needs to be upgraded, if you can expand the lifetime of it, you're actually having lots of operational savings. There's also lots of potential with digitalization and digital twins around virtual testing to validate whether a technical choice of evolution is sound, and to support in general certification of systems, which at the moment is partly manual, and that takes a lot of time to actually being able to bring new railway systems in production, and time is money, obviously. So to our approach of digital twins, so digital twins are usually trying to address a use case. Not every use case actually need super detailed digital twins. So what we can set to do is to start with more simple modeling of assets and evolve complexity over time, and doing that through a modular and composable component approach. so that eventually we can start taking benefits of digital twins in a first step, and then evolve their capabilities over time. And the next step, and what our members have actually expressed a strong desire to go towards, interoperable digital twins. So it's not about isolated islands of digital twins, but actually interconnecting them across systems, across suppliers. So that usually means standards, and also between in cross-border settings, which brings, by the way, cybersecurity aspects again, because we have international organizations in play. And to underlie it, we are developing a common data model, and also we can use the standard interfaces where they are available. And once we have those well-defined digital twin components with this shared data language and standard interfaces, we can start to federate them and ultimately get even more increased value by combining them together. And one of the projects I'm working on is around the development of ontologies for railways, notably rail system model developed by USC, which would come in as a complement to ontologies that are developed at the European level. It's called the ERA ontology, for the European Union Agency for Railway Ontology, which is focused on legal registers, so vehicle authorization, description of the infrastructure so that we can assess interoperability of the train with that infrastructure. But ultimately, the point is not to create all-encompassing standard that replaces all others, because we all know the XKCD cartoon about it. And so it's very important that we link it with international standards where available. One such example is in the BIM model, BIM space, so Building Information Modeling, where BSI, Building Smart International, has developed the IFC standards, and there is a IFC Rail chapter which develops rail-specific aspects of that standard, but ultimately we are already working on combining those BIM modeling with the railway modeling. And last but not least, a very strong emphasis on open licenses and open models, so that innovation is not behind the walled garden. Finally, regulation. I talked a lot about regulation. It sounds like it's a pain to railway. It is a pain to railways, to be honest. But it's more than this. It's actually providing a base of trust and safety for the railways. That being said, we need to find a ways to actually also introduce innovation on the side of this regulated use case, because that's where lots of the saving in operational optimization would be. And as such, we can essentially define certified cores of the digital model, combined with more fringe, I would say, description of the railway system, but focusing on semantics in order to facilitate interoperability, and eventually over time have a more complete description of the railway system. So it's a platform to actually do lots of other things. It's not just an end in itself as well. And so, just to summarize, we are looking at innovation in railways as an evolution because of this legacy. But this legacy is not only something we need to be afraid of. It's actually a recognition of the investment that was made into it, and the good and the fact that it's fit for purpose for lots of our usage. But we need to evolve in order, in particular, to optimize operation and save costs for the development of railways. One last thing of interest, that's my last slide, might be a bit out of time, but anyways, I wanted to take advantage of this forum as well to put some light on the Open Rail Association, which is an open source foundation that was created last year, which is to promote open source in railways. One thing that we note a lot in discussion with railways is they tend to solve the same problem in their own space. And so we encourage them to participate, and we encourage anybody to actually contribute to the work of that Open Rail Association. Thank you very much.